Hello students, and welcome to section 4-2, Angles of Triangles. To start today, we'll be taking a look at triangle angle sum theorem. If the measures of two angles of a triangle are known, the measure of the third angle can always be found. As you can see, the sum of the measures of the angles of a triangle is 180. This is a topic we have touched upon in the last section, wherein if again you add all three angles as they describe here, angle A plus angle B plus angle C, the measure of each respective angle technically is going to be equal to 180 when you add them up. Okay, so for example 1, you can see here that we are going to be taking a look at finding the measure of angle T. You see you've got a 25-degree angle for angle R, a 35-degree angle for angle S. We don't know angle T, but if we rewrite it as such, where the measure of all three angles added together is set equal to 180, therefore 25 plus 35 plus the measure of angle T equals 180. 60 plus the measure of angle T is equal to 180, and of course subtracting 60 will yield 120 degrees for angle T. Example 2. So for this particular depiction, we're trying to find, of course, the missing angle measures. In this case, we've got angle 1 and angle 2 that are not known, as well as angle 3 for that matter. It turns out that the measure of angle 1 plus the measure of angle A plus the measure of angle B, of course, is equal to 180. So we can find angle 1 really pretty nicely again, where if we add angle 1 plus 58 plus 90, set it equal to 180. Of course, that's 148 when added. When you subtract it from both sides, we get angle 1 to be 32 degrees. But that's not enough, of course. Noting, however, that vertical angles are congruent. Not only is angle 1 32 degrees, but so is angle 2. Therefore, in the next equation, you can see these three angles are going to add up, of course, to 180. Okay, let me actually make my notation here so you can see that, of course, these two angles are 32 degrees. Angle 2 is 32. So angle 3 plus angle 2 plus angle E is equal to 180. Add these three together, of course, and that's what you should see. 32 plus 108 in the next step, of course, is 140. Subtract 140 from both sides, and of course, boom, 180 minus 140 is 40 degrees. Angle 3 is 40. In the exercises, now I have completed them in advance to kind of nicely have you guys go through this. I do want to still write a few things down, but for example, you can find angle 1 by adding 62 plus 90, adding it, of course, to angle 1 and setting it equal to 180. If you add 62 plus 90, obviously we go ahead and do that, and we'll end up with 152. Subtract both sides, or subtract, 152 from both sides, and that's how you'll end up with 28 degrees. Number 2, same idea. Now for this particular question, however, be careful. You do have two angles that are congruent, but only because of the fact that this is an isosceles triangle. We have already discussed that if base angles are congruent, then the opposite legs are congruent. So that base angle that's not depicted yet with a number, which I've already then depicted as you see here while I was talking, is 30 degrees. So if you do the math where you add angle Q plus angle R, or if you prefer 2 times 30 degrees because they're congruent again, add angle 1, set it equal to 180, and we could do the math accordingly. We could take 180 minus 60, and there you have it. Angle 1 is 120 degrees. So this is an isosceles triangle with base angles of 30 and a vertex angle of 120. Let's go ahead and continue. So number 3. I have a depiction here of two right triangles, it appears, which, by the way, I'd like you to fill that in, that little right angle. Or if you're drawing it, make sure you have those two right angles. And then from there, we can assess that, well, we've got for angle 1, we've got a 90-degree angle plus a 60-degree angle, plus, again, the measure of angle 1 not being known. Add it, but also, of course, set them equal to 180. We do the math. We got 180 minus the sum of 90 and 60, which I would argue is as easy, of course, as 180 minus 150, of course, from there, and that's going to end up being 30. Okay, In a similar manner, on the other depiction, it's going to be 90, the other triangle, and this depiction algebraically 90 plus 30 plus the measure of angle 2. Set that equal to 180. This results in 30, while this results in 60. As a matter of fact, this is a special type of right triangle. It's called a 30, 60, 90 right triangle. I recommend you write that down because we're going to be spending quite a bit of time later with 30, 60, 90 right triangles, for example. Number 4. So number 4, in fact, in a matter of speaking, kind of looks like the example 2 from up above, where you have vertical angles to assess. So right away, I would argue you can mark that angle 1 and angle 2 are in fact congruent. I would also argue that the triangle on the left needs to be assessed first. So you take 68 plus, or 66, pardon, plus 58 plus the measure of angle 1 and set it equal to 180. If we do the math, not surprisingly again, simply 66 plus 58, which is 124. And if we take 180 minus 124, we get, of course, 56. The measure of angle 2, remember, is congruent or equal to, the angles are congruent, but the measures themselves are the same. So therefore, of course, this is also 56. So on the other depiction, if we go ahead and say what? We've got 56 plus 50 plus the measure of angle 3, set it equal to 180. 56 plus 50, of course, is 106. When we subtract 180 minus 106, we end up with 74. You could double check that if you'd like. I'm going to leave those last two problems, 5 and 6, for you to try on your own. They're both relatively straightforward, I would argue, but please try those two on your own using the same logic that we've applied thus far in the prior questions. Next page, continuing on. On this next page, we're going to discuss the exterior angle theorem. At each vertex of a triangle, the angle formed by one side and an extension of the other side is called an exterior angle of the triangle. For each exterior angle of a triangle, the remote interior angles are the interior angles that are not adjacent to the exterior angle. In the diagram below, angle B and angle A are the remote interior angles. Okay, and then the exterior angle, given those two remote interior angles, would be angle 1, or you could argue, as they also say, angle DCB. Here's the cool thing about all of these angles in context. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interiors. In other words, angle 1 in the picture is equal to angle A plus angle B. It's a quite nice theorem as we continue on here, and you'll see in example 1 and 2 how nicely it also unfolds. So find the measure of angle 1 in the picture. You've got triangle RST with an exterior angle there as angle 1. Okay, we'll go ahead and continue as such. In other words, the measure of angle 1, according to the theorem, is equal to the measure of angle R plus the measure of angle S. So we have 60, which is angle R, plus 80, which is angle S, and that easily enough is simply 140. So angle 1 is 140 degrees. A really cool thing you can check to see on this type of problem, you can check that, well, 140 plus 40 degrees is, of course, 180. And because obviously those are supplementary, you can do that first of all, but also noting now 80 plus 60 plus 40, 80 plus 60 plus 40 is in fact going to equal 180. So you can check your answer in a nice kind of manner in that regard. Example 2. So for this particular problem, they say find x, which is actually not an exterior angle, it's a remote angle. So the math works like this. PQS, which is exterior, PQS. We do know it to be 78. And also 55, which is the measure of angle R, another angle though, which is remote. We don't know this angle here, of course. But remember, angle R plus angle S, those two remote interior angles are going to add to equal, in this case, 78. 55 we know, X we don't. We subtract 55 from both sides, and we have X, therefore, to equal 23. Yet again, if you wanted to check your answer, all right, for example, if you wanted to come up with the supplementary or the angle that's in linear pair with PQS, we know that this is 102. And then if you wanted to continue by proving this or checking this, you could take 102 plus now 23 plus 55, and in the end you better end up with 180 degrees for the angle sum there. Let's do a few questions. I'll probably have you try a couple on your own later as well. So number one, find the measure of each numbered angle, of course. You're going to, hopefully you can see that adding the two remote interiors, 50 plus 65, will be equal to the measure of angle 1. And simply, of course, if you add, you end up with 115. Problem number 2, similar in that you can add 25 plus 35, and that is going to be equal to the measure of angle 1. And from there, of course, you can see that that's going to end up being 60 degrees. The supplementary angle, of course, angle 2, should just be 180 minus the angle you just got, so 60, and that, of course, ends up being 120. Number 3, this picture has, it looks to be two pairs of parallel lines, but it also happens to have angle 1, 2 as remote interiors of triangle NOP, angle 3 being the exterior, but also 60-degree angles here and here. Okay, so what we're going to go ahead and do is we're going to do an analysis of alternate interior angles, these two angles being alternate interiors, so you know that this angle must be also 60 degrees. I'll reiterate the theorem if you recall. If lines are parallel, then alternate interior angles are congruent. And the same holds true on the kind of other end of things where this angle is congruent to that angle. Because again, NO is parallel to MP. These two angles are both congruent. They're 60 degrees. If lines are parallel, then alternate interior angles are congruent. So we haven't yet used the new theorem. However, knowing now that angle 1 and 2 are both 60, you could even go one step further and say this is 60, because what's 180 minus 60 plus 60, the sum of the two angles, 60 and 60 being 120. Well, 180 minus 120 is also 60. You can use the idea of linear pair here to find this angle, of course, 180 minus 60 in that regard then being 120. If you did use the new theorem, however, not surprisingly, you could say 60 plus 60, angle 1 plus angle 2 added, and then that should equal, that should equal the exterior angle 3. And of course, that is the other way you could have done that. Let's finish up with number 4. So with number 4, there are many triangles actually in context, so be careful with how you're interpreting things. I would argue that angle 1 is the first angle to calculate because you can take 180 minus the sum of 35 and 36. And if you do that, you'll end up with 109. Okay. Now that you have 109, you can use that in conjunction with what? This angle, where you can take 180 minus 109 to get 71. So again, those are a linear pair. We haven't yet used the new theorem, but I think now is the time to do that, where if I'm asking you to find angle 2, recall again, looking at the picture, I know it's a little bit tricky now, but angle 2 plus 80 should be equal to the exterior angle of 109. So if you take 109 and subtract 81, you do get, 109 minus 80, not 81. You in fact do get 29 degrees. Please try numbers 5 and 6, and of course do the homework for tonight as well.